Hello everyone, how are you all? Hope all you are fine. So in my earlier lecture, I have discussed there about that is structural isomer and branching in chain. So today we'll discuss about ring of carbon and that is functional group. So what is ring? See, when carbon it is arranged in a closed figure, that is considered as a ring. See, if I want to draw the ring structure of carbon, I can only draw from the third member from the alkene and alkynes. Okay, so let me check. You see, we have what? Alkane. The first member of alkane is methane, ethane, and third one is what? Propane. Okay, so we can draw from propane. See, 3 carbon is there. C3H8. Okay, this is the what? Propane. Okay, if I draw the what? Ring of this structure, see, if I arrange carbon in this way, okay, then here hardly I can place 2 hydrogen. Here also I can place 2 hydrogen. Here also I can place 2 hydrogen. Okay, if you count the what carbon, okay, C3 is 6. 1 2 3 4 5 6. So hydrogen is what? 6. Okay, so this is the formula of cyclopropane, where 2 hydrogen is less than that of propane. Okay, this is the what ring structure of what cyclopropane. Okay, now let me draw for that is butane. What is the formula of butane? C4H10. See, if I arrange carbon in this way in a closed figure, okay, if I add here hydrogen, so hardly 2 hydrogen I can place, because you know the tetravalency of carbon is what? 4. This is the structure of what? Cyclobutane, and the formula is what? C4H8. This is the what? Cyclobutane. Okay, so in this way we can draw what? Cyclopentane also. Generally the pentane formula is C5H what? 12. So cyclopentane, you see, I can draw in this way. Then this is the what? Cyclopentane. Here, here, everywhere, one on what? Hydrogen you can give or not, in this way. So the carbon is what? C5 and hydrogen is what? 10. You see, 1 2 3 4 5 6 7 8 9 10. That means 2 hydrogen is less than that of, that is called pentane. Okay, so like that we can draw for the hexane. Formula C6 is 14. See, if I arrange the carbon in this way, if I arrange the carbon in this way, this is the structure of what? Cyclohexane. Okay, this is the structure of cyclohexane. Okay, so where carbon will get how much? 6 carbon and hydrogen 12. 1 2 3 4 5 6 7 8 9 10 11 12. Hydrogen is what? 12. Okay, that means 2 hydrogen is less than that of hexane, and this is the formula of cyclohexane. Okay, so in the same way we can draw for the what? Alkene and alkyne. Let me show you. So alkene, and already I have said ring structure only can be possible from the third member of the carbons in case of alkane, alkene and alkyne. See, the third member of the alkene is what? Propene, C3H6. This is the what? Propene. If I draw the ring structure with this propene, you see here like that, 1 carbon, and since it is alkene, at least in somewhere in this ring I need to add double bond. Now with this carbon already 3 bond is there, so 1 bond. With this carbon already 1 to 3 bond is there, I can add only 1 bond. With this carbon also I can add only 2 bond, because Surrounding this 2 bond is there, so 2 more. Okay, now what is the formula of this? I mean what? Propene C. C3 hydrogen 1, 2, 3, 4. Okay, this is the what? Cyclopropene. Okay, where 2 hydrogen is less than that of propene. Are you getting my point? Okay, let me show you for the butene. Okay, butene formula C4H8. Okay, if I draw the structure of butene, okay, that means at least in one place I can put double bond like that because it is alkene. So with this carbon 3 bond is there, here 1 hydrogen I can place. With this carbon already 3 bond is there, 1 hydrogen I can place. Here 2 bond, that means 2 more bond I can add. With this carbon also I can add 2 more bond. Okay, now let's see the formula. 1, 2, 3, 4, carbon 4 and hydrogen, there is what? 1, 2, 3, 4, 5, 6. 6 hydrogen is there. That means 2 hydrogen is less. You see, 2 hydrogen is what? Less than that of butane. This is the structure of what? I mean cyclobutene. Cyclobutene. And in this way, we can draw for the alkyne. Now, let me show you that. And rest of the other member of, I mean, cyclopentene, okay, cyclohexene, you just try at your home. Now, let me show you for the what? Alkyne. What is the, I mean, third member of the alkyne? That is propyne, C3H4. Okay, so if I draw the ring structure of what? Propyne. Okay, since it is alkyne, here I will give what? Triple bond. So with this carbon I cannot add what? Hydrogen. With this carbon also I cannot add hydrogen. But with this carbon I can add what? Hydrogen. Okay, so what will be the formula of that is called propyne? See, C3H2. This is the formula of cyclopropyne, where 2 hydrogen is less than that of that is propyne. Okay, so in the same way you draw for the butane pentyne. Okay, now let me discuss about heteroatom. What is heteroatom? Okay, let me first draw one structure. Suppose this is the word carbon chain. Okay, so everywhere there is hydrogen. There is what? Hydrogen. Okay, everywhere there is hydrogen. Okay, so what is the name of this? I mean compound 1, 2, 3, 4, 5. I mean pentane. See, in a hydrocarbon chain, if I replace one hydrogen with another atoms, okay, in such a way so that the valency of this carbon remains satisfied, and this atom is known as heteroatom. Okay, let me save the definitions. What is heteroatom? In a carbon chain, when one or more hydrogen can be replaced with other atoms in such a way that their tetravalency of carbon remains satisfied, and those atom is known as atom. Here chlorine is heteroatom because the valency of chlorine is what? 1, and the valency of what that is called hydrogen, it is also 1. In this case, I mean both are satisfied. Okay, so chlorine is heteroatom. If I add here, suppose that is there is what? Br, bromine. Okay, that is also called as heteroatom. Okay, now this heteroatom can be remain in groups, and that is called as functional group. Okay, actually what is functional group? See, if you just place those atoms, for placing those atoms, if the whole properties of this compound is changed, that atom is known as functional group. See, earlier it was hydrogen, the name of this compound is pentane. If I add here Cl, now whole properties of this compound is changed. Now it falls under the functional group of halogen. Okay, and this is known as functional group. If I place here chlorine, the name will be what? Chloropentane. because 5 carbon is there, 1 2 3 4 5. So name will be what? Chloropentane. Just for placing this functional group, whole chemical properties of this compound is same. Okay, so if you want to make the definition of functional group, we can say in this way. So when an atom or group of atom, okay, in a carbon chain represents the what specific properties of that carbon chain, and those atoms is known as what? Functional group. Okay, now let me discuss about functional group. There are what? Several functional group. The first functional group I am going to discuss here, halogen. Okay, so under this halogen we have fluorine, next we have bromine, next we have that is called chlorine. Okay, next we have called iodine. Okay, and for the halogen functional group we have prefix. We have what? Prefix. Okay, prefix means what? It is just attached before the carbon chain. When I will take example, you will understand at that time. See, prefix of fluorine is FLUORO, fluoro. Okay, prefix of bromine is BROMO, bromo. Prefix of chlorine is chloro. Prefix of iodine is iodo. Okay, and the formula of F is what? F, Br, Cl, and I. That means if in a carbon chain, okay, suppose this is your carbon chain. Okay, this is your what? Carbon chain. Okay, here there is hydrogen, here is also hydrogen, here is also hydrogen, 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 okay, hydrogen. But if here there will be what? I. That means this compound falls under the functional group of what? That is halogen. If there is I, okay, the name will be what? Iodo. Since there is how many carbon? 1 2 3. For 3 carbon, 2 whom we call propan. So iodo, propan. But you have to mention the position here. So this functional group is in which position? Second position. So I can write 2 iodo pro. The chemical name of this compound is 2-iodopropan. Okay, if here there will be Br, that means it is the functional group. Which functional group? Halogen. What is the prefix of Br? That is bromo. What is that? Bromo. You have to write here 2-bromopropan. Okay, that means prefix means it is always attached. This is the carbon chain. This is the what? Carbon chain. Okay, this is, or we can say root word, and this is the prefix. Okay, and suffix is also there. Is it clear to you? Okay, if there will be what? Like that, more carbon there will be. That means it is now what? 1 2 3 4 carbon, and this there is a functional group of what? Halogen, and for Br we have a prefix bromo. Okay, since this functional group at what position? Second position in this carbon chain. So 2 bromo what? 4 carbon. So butane. Okay, so this is for what? Halogen. If here is Br, bromo, if there will be what? I, that means iodo, butane. If there will be F, what? 2-fluorobutane. If there is Cl, 2-chlorobutane. So in this way it will go. Okay, so now let me discuss second functional group, that is alcohol. Okay, now alcohol, okay, it has suffix. It have what? Suffix. The suffix of alcohol is what? OL. Okay, and the formula will be OH. That means in a carbon chain, okay, if you will get OH like that, suppose this is the carbon chain, suppose here if you get OH, that means it falls under the which functional group? Alcohol functional group, and it has only that is suffix. suffix means what? After the carbon chain it will attached. If you name this carbon chain, it will be in this way. You see, 1 2 3 4, for 4 carbon, to whom we called bu, and see this alkane, single bond is there, so an. See, the spelling of butane is butane. So here I cannot write e, the e should be delayed like that, and you have to mention the position. This alcohol is in which position? Second position. Okay, this is 2. Okay, and now what is the suffix of this alcohol? All. So the chemical name of this structure is butan2-ol. Okay, dear student, here hydrogen is there, here hydrogen is there. Okay, I have not mentioned it like that. Here hydrogen is there. Okay, okay, this is the structure of what? Butan2-ol. Okay, suppose, see this, here somewhere there is functional group. Okay, okay, let me take this example. 1 carbon, for 1 carbon whom we call meth, since it is a what? Single bond. So the name of this compound is methanol, because OH means what? Alcohol, and the suffix is ol, methanol. If there will be 2 carbon, ethanol, 3 carbon, butanol. Okay, I can write this chemical name in this way also, methan 1 ol, because it is in first position. Okay, so let me take the example of this. See, if you just add here 1 OH. Okay, how many carbon is there? 5 carbon is there. How many carbon is there? 5 carbon is there. So for 5 carbon, to whom we call? That is, for 5 carbon we may call as pentane, and since there is what? Alcohol. Okay, so pentane, so this falls under in which carbon? Third carbon, so 3 ol, so pentane 3 ol. Is it clear? Okay, so let me rub it. Okay, now let me discuss for the, that is second, third functional group, that is aldehyde. aldehyde, aldehyde. Okay, so aldehyde, the suffix of aldehyde is al, is what? Al, and formula of this aldehyde, that means in a carbon chain there will be like that, double bond O, and it should be in the end portion of the carbon chain. It will be in the what? Terminal portion of the carbon chain. Let me show you the example. Wait, suppose this is your carbon chain. Okay, if here, if it will be like that, double bond O. Okay, double bond what? O. If here will be what? Double bond O, this is what? Falls under the functional group of functional group of aldehyde. Okay, where you see double bond O is there. Okay, if you want to name this compound, see 1 2 3 carbon, so 3 carbon means what? That is propane, and suffix, yeah, it has a suffix of what? L, so propanal, A L. Okay, propanal. Okay, or I can say like that also, propan 1L, because in the first position, and it will be always in the first position, because this double bond O, if it is in the middle of the carbon chain, then it will fall under the ketone functional group. Okay, so let me take more example. Suppose here double bond O. What is the name of this compound? 5 carbon. For 5 carbon, whom we call? Pentane. Okay, and since the suffix of this aldehyde is L, so pentanal, P-N-T-A-N-A-L, pentanal. Okay, so like that you have to name the chemical compounds. Okay, and only you should remember this aldehyde. Okay, the suffix is L, and double bond O, there will be terminal portion of the carbon, either in that side, either in this side. Okay, so if double bond O, if it is here, now this not falls under the aldehyde functional group. Now this falls under the ketone functional group. What functional group I am saying? Ketone functional group. Okay, and for ketone we have suffix, what you know, on. What I'm saying? On. Okay, and it will always attached where? In the middle of the, I mean, there is carbon. Okay, see, if I want to name this chemical compound, here 5 carbon is there, 1 2 3 4 5. That means pen 10, e should be delete. Okay, this functional group in which position? If we count from here, it is in second position. If you count from there, 1 2 3, it is in fourth position. So according to the IUPAC, we have to always select the lowest one. That means pentane 2. What is the suffix of this, I mean, ketone? On. Okay, so you write here on. So pentane 2 on. Okay, if you just add here more one carbon, it will be hexane 2 on. What? Hexane, okay, 2 on. Now if you place this what double bond O here itself, it will be what? Hexane. The position is changed. If you count from here, then also it is in third position. If you count from there, it is okay. If you count from there, it will be in where? Fourth position. So always we have to what? Select the lowest one. So hexane, that is 3 on. 1 2 3 4 5 6. So hexane, it is in third position, 3 on. If you count from there, it will be in fourth position. So we cannot take the longest one. So hexane 3 on. The chemical name of this structure is what? Hexane 3 on. Okay, so let me rub it. Okay, see, if double bond, this double bond O, it will be here. Now it is not ketone functional. It is now what? Aldehyde functional group. And the suffix of the aldehyde is L. What? L. That means if I want to name this carbon chain, hexanal, ACXANAL. Name of this compound is what? Hexanal. Okay, so next functional group we have, that is carboxylic acid. Carboxylic acid, and for that suffix we have oic acid. Oic acid. Okay, so if in a carbon chain, okay, if in a carbon chain there is double bond O and OH, okay, this is the what? Carboxylic functional group. And you should remember, this will be always in the what? And this will be always in the what? And in the terminal portion of the carbon chain, if there is like that double bond O, OH, then it is called as what? Carboxylic acid. It cannot be in the middle. Why? Because it contains two functional groups. You see, one again here is one. If it is be in, if it will place in middle, then the tetravalency of the carbon will not follow. That is why, I mean, carboxylic functional group, it will always in the terminal portion of the carbon chain. Okay. Now, if you want to name this chemical compound, it will be like that. See, 1 2 3 4 carbon is there. No, for 4 carbon, to whom we call bu 10. Okay, what is the suffix of this carboxylic acid? Oic acid, that is butanoic acid. BUTAN, you just add this OIC acid. Butanoic acid. Okay, the name of this chemical compound is butanoic acid. If you remove one carbon, it will be what? Propanoic acid. What? Propanoic acid. If you remove again one carbon, it will be what? Ethanoic acid. What? Ethanoic acid. If you remove again one carbon, okay, you place here hydrogen, then it will be methanoic acid. Is it clear to you? Okay. Now let me rub and let me discuss the what? Sixth functional group, that is alkene. It is unsaturated. The what? Unsaturated. Suppose in a carbon chain, if you have like that, if you have like that double bond, okay, now this is the functional group which falls under the what? Alkene. Why it is functional group? Because it can show the addition reactions, it can show the what? Substitution reactions. Okay, now if you want to name this what? Chemical compound, the name will be in this way. You see 1 2 3 4 carbon is there, so for 4 carbon we may write bu. Okay, and what? Sorry, but. This double bond in which position? If you count from here, it is in first position. No, but 1, and see this double bond in. So but 1 in. The chemical name of this compound is what? But 1 in. Okay. Now, if here, if again I give what, that is, suppose triple bond, let me give here. Okay, now the chemical name will be, that is 1 2 3 4 carbon is there, so but. Okay, now see, in the first carbon there is alkene, in the second carbon there is alkyne, because triple bond is there, so alphabetically E comes first. Okay, what? E come first. Okay, alkene, in a carbon chain, if there is double bond and if there is triple bond, so first of all you have to mention the alkene, then alkyne. So but 1 in, okay, 2 wine is the chemical name, because this is the what? Parent chain, 1 2 3 4 carbon is there. So at the first carbon there is alkene, so ene. Okay, at the second carbon there is alkyne, so this means what? This 2 means what? It is in what? Which position? Second position. What is there? Yne is there. Okay, so now see, if I rub this, okay, if what? Both are double bond in a carbon chain, what? Double bond is there. Okay, 2 double bond is there. In that case, the naming will be little bit different, you see. So since 4 carbon is there, so but. Now since here is, I mean what, 2, I mean double bond is there, that is why I have to add here 1a. Buta, what? Buta. This is the first position, this is the second position from this side. If you go count from that side, 1 2 3, okay, it will be what? Longest one. Always we have to choose the lowest ones. That means buta. Okay, 1 double bond is in which position? First position. Again 1 double bond is in which position? Second position of carbon. So buta 1 comma 2, since 2, that is, I mean double bond is there, so di ene, in. Why in? Because it is alkene functional group. The chemical name of this what? Buta 1 comma 2 diene. Okay, so for today this much. Okay, so we will meet in our next class. Thank you.